Hello, Algebra 1 students, and welcome back to your Semester 2 final review. We're on to problem 30, and you might have noticed on problem 30 it has the dreaded none. And that just tells us that throughout Semester 2 we didn't really cover what's happening on this problem, right? We didn't actually have a lesson on it. However, some good news, you do actually know how to do this problem, and the answer is not going to surprise you too much. It all has to do with HK form. So I'm going to try to explain what's happening here in a general sense, and then we'll go back to the specific problem. So the idea here is that we're going to be using function notation. And a reminder, function notation is f of something, right? And a lot of times we find f of a number. So we'll use the example that they have up here, f of x equals x squared. And if they want us to find f of a number, like, I don't know, 3, then that means take whatever the x is and replace it with 3. And so then we can see that f of 3 would be equal to 9. Well, what we're going to do here instead is, instead of substituting a number in for x, we're going to replace x with a minor equation, technically an expression, something still with x. So in the case of this problem, they're asking us to replace x with, take a look at this, x plus 7. But the same thing applies. We take whatever the x was and we replace it with x plus 7. And we get x plus 7 squared. Now, instead of getting a number, we end up with an equation or an expression here. Now, what they want us to do is explain how the graph is going to change if our new equation is x plus 7 squared instead of x squared. Well, this all comes down to HK form. And our original function was x minus 0 squared plus 0. Remember HK form? We covered that in the last two videos if you want to jump back to 28, 29. And this one is x plus 7 squared just plus 0. So they're saying, here's where we started, here's where we are ending. How do the graphs compare to each other? Well, this graph has a vertex, and I'm going to quickly sketch this out here. It doesn't have to be perfect. This graph has a vertex of 0, 0, right? We can see our vertex right here. And an a value of 1, up 1 over 1, up 1 over 1. So we have a parabola like this. However, this second graph has a vertex of negative 7, comma 0. 1, 2, 3, 4, 5, 6, 7, negative 7, comma 0. Still an a value of 1, up 1 over 1, up 1 over 1. And it looks like this. So their question is, if we do f of x plus 7, how does it change our graph? Well, it changes our graph by starting at the green and shifting over to the blue, so it looks like we shifted 7 units to the left. So I'm getting an answer of C here. Now, I will tell you that although all of this gives you a concrete example, there is an easier way to do this problem. And the easier way to do this problem, and I'm going to give you two more examples here, is let's say that we have some unknown function f of x. We're going to say we have a function called y equals f of x, and it makes some graph. Doesn't matter where the graph is. And they said, okay, we're going to make a new function called g of x. And g of x is going to be based on f of x. It's going to be f of x minus 3. How are those functions related? Well, this relationship here is all about HK form. And I'll give you a couple other examples, maybe some easier ones. We'll say, what if we made g of x a different function? It was f of x plus 1 minus 2. Right? Or we said g of x is some new function, and it's f of x minus 3 plus 1. How is that related? Well, each of these transformations are based on an a times f of x minus h plus k. And we have seen these before, right? A is going to change the slope. H is going to shift our graph horizontally. And so that's going to move it left and right. And then k is going to shift our graph vertically. And so that's going to move it up and down. So I can actually very quickly identify how these are changing my graph. For example, on this first one, minus 3, that's the h of our transformation, and we know h is always the opposite. So this would be 3 units instead of minus 3, instead of horizontally to the left, it's the opposite. So 3 units right. It would look like this. These next two, and I'm going to need a little bit more room, but that's all right. These next two have two different transformations, and so we need to identify both of them, right? The opposite of positive 1 is negative 1, so we would say 1 unit. Instead of to the right, we think of a minus, so it's 1 unit left. Yeah, because this positive 1 would move us left. And then minus 2 is the k, and so that would move me 2 units down. Negative 2 means move down. All right, if you look at this last one, minus 3, opposite of h, so we'd go right 3, and plus 1, we'd go up 1. So we'd say right 3, up 1. So when they ask us about this transformation over here, f of x plus 7, think of it as f of x plus 7 plus 0. This plus 7 means go left 7 and up or down 0. And so we don't even need the graph here. If they want to know how it changes, this f of x plus 7 just means shift our graph 7 units left, because it is actually HK form that we're applying. Hopefully that helped you guys out. You might expect one problem like this on your final exam. If you want more examples of this, because we didn't actually learn this, just let me know, and I'm happy to post another video or give you a worksheet where you can get some practice in. Thanks as always, and hopefully you're finding success on that final review.